Let's do the next question. Here the question is, in the given network, find the value of V1, V2 and V3. Okay, V1, V2 and V3. Right? And in this question, the only difference is that now there is a dependent source, right? Dependent source. This is what is the name? This is a voltage source, which means this is a voltage controlled voltage source. Okay, and this is the value of this voltage source is 4 Vx. So what is Vx? This is Vx. Vx is the voltage across the 1 ohm resistor. Okay. So like I said, even if there is a dependent source also, you just have to consider it as a normal source. The only difference is that you need to express the equation of Vx. So here, what is Vx? Vx is the voltage across the 1 ohm resistor. Or what is 1 ohm resistor? What is the voltage across 1 ohm resistor? Make an equation for that. What is the voltage across the 1 ohm resistor? Right? You can see over here that this is plus and this is minus, which means V2 is higher potential and V1 is lower potential, right? Vx is the voltage across this resistor, and on one end of the resistor is V2 and the other end of the resistor is V1. And also since the Vx is marked like this, plus and minus, which means this is higher potential, this is lower potential. So therefore, what is the value of Vx? V2 minus V1. That's all. Okay. So now anywhere, wherever you see it, just like your mesh analysis, anywhere if you see Vx, substitute Vx as V2 minus V1. That's all. Okay. So now let's do this question. So here, find the value of V1, V2 and V3, right? So this is V1, V2 and V3. The three nodes are there. So let's write the equation for every node. First I'll write the equation for V1, okay? So therefore, equation for node V1, right? Equation for node V1. So if you look over here, V1 has this is the node, right? And this node has how many branches? 1, 2, 3. 3 branches, right? So 3 branches means there will be 3 terms, okay? And all of them are assumed to be outgoing, which means all the currents are positive, will be assumed to be positive, which means V1 will be considered as the higher potential. That's what it means, okay? So which means, what is the current through this branch? The current through this branch, already there is a current, according to this question, already there is a current called 2 amperes which is flowing into the junction, which is incoming. It is flowing into the junction, or in other words, it is going the opposite of the direction that you have assumed. So in other words, the value of this is minus 2. So this is the first term is minus 2. Okay, the first term is minus 2 amperes because this is an incoming current. All outgoing currents are considered as positive, whereas incoming current is considered as negative. And see, this current is going into the junction, therefore it is minus 2. Or on other way of explanation, it is opposite to the direction that you have assumed. See, you are assuming that there is an outgoing current, right, that's flowing in this branch, but this 2 amperes is going into it, opposite of this current. That's why it is minus 2. Okay, plus, now what is the current through this branch? It is V1 minus 0 by 2, which is nothing but V1 by 2. Plus, what is the current through this branch? It is V1 minus V2 by 1. V1 minus V2 by 1. That's it, right? Only 3 branches. So no voltage source or anything. So it will be equal to 0. That's it. Right? So here, now I'm going to write in terms of V1 and V2. So this will become V1 into 1 by 2 plus 1 minus V2 into 1 by 1 is 1 itself, right? Is equal to, and there's no other constants other than, so this minus 2 will become plus 2. What is 1 by 2 plus 1? That is become 1 plus 2 by 2. That is 1 plus 2 is 3. So 3 by 2. 3 by 2 is 1.5, which means this is nothing but V1 into 1.5 minus V2 into 1 is equal to 2. Okay, this is equation 1, right? Next is equation for node V2, right? Equation for node V2. Okay, so here V2 has, this is V2 has 1, 2, 3 branches. So first I am going to write the current across this branch. And what is the current across this branch? V2 minus V1 by 1, right? So V2 minus V1 by 1 plus Next is V2 minus 0 by 2, which is V2 by 2. V2 by 2. V2 minus 0 by 2. So V2 by 2. Next is V2 minus V3 by 1 plus V2 minus V3 by 1 is equal to 0. That's it. Right? So now I'm going to express in terms of V1, V2 and V3. So this will become minus V1 into, there is no other term, right? For V1 only this. So it is 1. Okay. Plus V2 into, and what about V2 has 1 plus 1 by 2 plus 1 minus V3 into 1 by 1 is 1 is equal to 0. Right? This is the term. Or in other words, this will become minus V1 into 1 plus, what is this? This is 1 plus 1 is 2. 2 plus half is 2 and half, 2.5. So this is V2 into 2.5. V2 into 2.5 minus V3 into 1 is equal to 0. This is equation 2. Okay. Now next will be equation 3. Equation for node 3. So equation for node V3, right? V3. So that means here, let me see, V3 has how many branches? 1, 2 and 3. Oh, and you don't have to write those branches also, right? Because you see here there's a voltage source in between V3 and 4Vx. You see, so the equation becomes more simpler. You don't have to write the node V3 because V3 is already given. You see, V3, what is V3 over here? If you look very carefully, you don't have to write the equation. There's no need of writing these two equations. See, because if you look over here, V3 is, this is the voltage V3 and this is 4Vx that you see over here is 4Vx, which means this one end of the voltage is V3 and the other end of the voltage is 4Vx. And what is the voltage between V3 and 4Vx? It is 2 volt. You see, the voltage between V3 and 4Vx is 2 volt. Or in other words, V3 minus 4Vx is equal to 2 volt. You see, because the potential difference between V3 and 4Vx is 2 volt. The potential difference between V3 and 4Vx. The potential difference between V3 and 4Vx is equal to 2 volt. That's it. You see, so in that case you don't have to write. Or in other words, you can also say that V3 is equal to, you can see that V3 is nothing but the voltage in series to this. What is the voltage in series? You see, this is plus minus, which means these two voltages are in series with each other. Series means it will be, we will be adding the voltage sources, which means it will be 2 plus 4Vx. So therefore V3 is equal to 2 plus 4Vx. V3 is equal to 2 plus 4Vx. You can write like that. You can start like that. You see, both the equations are the same. Both the equations are same, and now it depends on which thinking is more comfortable for you. Either you can assume that this is another voltage, this is another voltage, and across in between these two voltage there's another voltage source, which means the difference between this voltage and this voltage is this voltage. That is the first explanation. That is the first explanation. Or you can apply the second explanation. The second explanation is that you can say that V3, the voltage V3 is nothing but, see, there is no resistor or capacitor or anything over here except voltage sources, which means V3 is nothing but 2 volt plus 4Vx. Why it is plus 4Vx is because this voltage source and this voltage source are in series with each other. So that's why it is V3 is equal to, so you can apply any two method, you will get the same equation. Okay. Now, like I said before, wherever you see the dependent source value, replace that with the equation. So Vx, right? We already know what is Vx. Vx is V2 minus V1. So substitute that over here. So you will get V3 minus 4 into V2 minus V1 is equal to 2. Or in other words, I could say that V3 minus 4V2 plus 4V1 is equal to 2. Or for my own convenience I am writing V1 into 4 minus V2 into 4 plus V3 is equal to 2. So now this is equation 3. So therefore expressing equations 1, 2 and 3 in matrix form, so here the coefficients are, here it is 1.5, the coefficient of V1 is 1.5, the coefficient of V2 is minus 1, and the coefficient of V3 is 0. There is no V3 over here, so that means 0 into V3. So coefficient of V3 is 0, right? This is the first equation. What about the second equation? Minus 1, 2.5, minus 1. Minus 1, 2.5 and minus 1. What about the third equation? It is 4 minus 4, 1. 4 minus 4, 1. Into V1, V2, V3 is equal to, now what are the constant values? In the first case it is 2, the second case is 0, and the third case also 2. So it is 202. 202. There. Now I can find the value of V1, V2 and V3. First I will find the value of V1. Okay. So V1 is equal to the determinant of replacing the first term with this. It will become 202 minus 1, 2.5 minus 4, 0 minus 1, 1 divided by, and your denominator will be 1.5 minus 1, 4 minus 1, 2.5 minus 4, 0 minus 1, 1. Okay, and this is nothing but, this is equal to, let's see, this is 2 into, this is 2.5 minus this, and this becomes plus, right? So it is 2.5 minus 4, 2.5 minus 4 plus 1 into, let me see, plus 1 into, this is 0 plus 2, so means this is 2. Okay, divided by, this is 0 into, so you don't have to consider that, and divide by, now let's see what's the denominator. The denominator is 1.5 into, this is 2.5 minus 4 again, 2.5 minus 4, okay, plus 1 into, this is minus 1, and this is minus 4 becomes plus 4, right? This is the equation you get. So let me see what you get over here. It is, let me see, 2.5. Let's find that equation. Here I am going to find the numerator denominator separately because I need the value of denominator for finding V2 and V3, right? So this is 2 into 2.5 minus 4. 2 into 2.5 minus 4 plus 2. And you will get is minus 1. So this is equal to minus 1 by, now let me see what is the value of the denominator. It is 1.5 into 2.5 minus 4, 2.5 minus 4, and this is 4 minus 1 is 3, so plus 3, right? Plus 3, and you will get is 3 by 4 or 0.75. So the denominator is 0.75. In other words, the answer is minus 1 divided by 0.75, which is equal to minus 1.333. Minus 1.333 volt. This is the value of V1, right? Now next I'm going to find the value of V2. So to find the value of V2, 1.5 minus 1, 4. 1.5 minus 1, 4. The second column will be 202. 202. And the third column will be same 0 minus 1 1. 0 minus 1 1. 0 minus 1 1 divided by, okay, and the denominator is 1.5 minus 1 4. 1.5 minus 1 4 minus 1 2.5 minus 4 and 0 minus 1 1. Okay, so let's find the value of V2. So here the denominator is 1.5 into 0 and minus 2 becomes plus 2. So it is plus 2 minus 2 into this is minus 1 plus 4, right? Minus 1 and this will become plus 4 divided by, we already found the denominator, right? What's the value of denominator? 0.75. So just simply write that over here, 0.75. So what do you get is, let me see. So this is obvious that 1.5 into 2 is 3, right? So 3 minus, and what is this? This is 4 minus 1 is 3. 3 into 2 is 6. So this is minus 6, right? Minus 6 divided by 0.75. So let me put this in the bracket. Divided by 0.75. We have minus 4. So V2 is equal to minus 4 volt. V2 is equal to minus 4 volt. Next is V3. V3 is equal to determinant. Here the third column will be different, right? So it is 1.5 minus 1 4 minus 1 2.5 minus 4, and then here it will become 202 divided by, and the denominator will be the same, 1.5 minus 1 4 minus 1 2.5 minus 4 0 minus 1 1. Okay, so this is, let me just find the answer. This is 1.5 into 2.5 into 2 is 5, right? 5 minus 0. Then here it will become plus 1 into, okay, plus minus becomes plus, so plus 1 into, this is minus 2, right? Minus 2 minus 0, so it doesn't matter. Next is plus 2 into, this is 4 minus, plus 4 into 2.5, 4 into 25 is 100, so 4 into 2.5 is 10, right? So this is 10. This is 10 divided by 0.75. This is equal to, what is 1.5 into 5 is 4.5, I think, right? 4.5 minus 2, and this is 4 minus 10 is minus 6. Minus 6 into 2 is minus 12 divided by 0.75. So therefore the answer is, let me see, 4.5 minus 2 minus 12 divided by 0.75, and you will get is minus, let me check if I made a mistake in there. 1.5 into 5 is, sorry, I made a mistake. 1.5 into 5 is 7.5, not 4.5. 1.5 into 3 is 4.5. This is 7.5. So which means 7.5. You put a bracket over here. Yeah. 7.5 minus 2 minus 12. 7.5 minus 2 minus 12 divided by 0.75. And you will get is, hope this is correct, minus 8. Let me check the answer is correct. Yeah, it's correct. So minus 8.667. So the answer is equal to minus 8.667 volt. This is the answer for V3. So therefore, you can write the answer. V1 is equal to, what's the value of V1? Minus 1.333 volt. Okay. V2 is equal to minus 4 volt, and V3 is equal to minus 8.667 volt. This is the answer. Okay.